So looking at Unit 1.5, if we remember back when we did our spaghetti and meatballs, we said that a relation is a set of ordered pairs which can be represented by a set of ordered pairs. It's somewhat redundant. We could also use a table, a graph, or a map. Now, a special type of relation is a relation in which each element of the domain, and the domain is our x values, is paired with exactly one element of the range, which is our y values, and this is called a function. And if you remember from last week, we talked about how we can use a vertical line test to determine if a graph represents a function or not. If we draw a vertical line down the graph and the line only touches the graph once, then the graph represents a function. Now that should have been review, but this third part is pretty different. When we talk about the function notation, it's another way to write expression or equations that have both x and y. So instead of using y to represent the range or output, we use f of x. And it's not the same as f times x, because f is the name of the function, not the variable. So we pronounce that f of x, and you might sometimes see g of x and h of x. We're going to go more into that tomorrow, but today let's start identifying functions. So if we have maps, we look at this first one, we have our domain and our range. Our domain is listed on the left. It's -2, 0, 4, and 5. And don't forget our fancy brackets. Our range is, 0.5, 2.5, and 6.5. So we have to decide if it's a function or not. Well, yes, this is a function because there's no x value that's paired with more than one y value. So this first one is a function. And then if we look at the second one, we've got our domain on the left and range on the right. Our domain is 4, 5, 6 in our fancy brackets. Our range is 3, 4, 5, and 8. We have to decide if this one's a function. Well, we have the number 6 that's going to both, it's paired with 4 and 5. So if an x value is paired with more than one y value, then no, it's not a function. It's still a relation, but it's not a function. So if you flip to the back, we're going to make a map. So looking at number 3, we list out our domain, our x values, and we always do it in numerical order. So we've got 4.2 listed twice, but we're only going to write it one time. We don't write it twice for our maps. Now we write our range, which is 0, 1.5, 2.2, and 4.8. And we draw our arrows to connect our domain with our range. 4.2 goes with 1.5, 5 goes with 2.2, 7 goes with 4.8, and 4.2 goes with 0. So because 4.2 is paired with two y values, then no, that's not a function. If we were to graph that, it would not be able to pass our vertical line test. So if we look at number 4, we list out our domain, and again we're doing it in numerical order, not necessarily the same way that it's listed with our set of ordered pairs. Now we write out our range. Again, it's in numerical order, so we start with the -7 and work our way up. And we draw our arrows to show how each value is related to the other. So -1 is paired with 1, -2 is paired with 2, 4 is paired with -4, and 7 is paired with -7. So is this a function? Well, every x value has its own y value. So yes, it is a function. And if we look at 5, we're just going to use our vertical line test. I'm not making use sentences to explain. I'm just drawing vertical lines down my graph, and at every one it intersects the graph only one time. So yes, that one's a function. But with our second one, if I draw a line right here, then you see it touches twice on the graph. So no, it doesn't pass. It's not a function. It's still a relation, but not a function.